when we left off on Friday, we had just covered addition and subtraction with significant figures. So we talked about how when you add and subtract numbers, you go to the last common place. So if they have the one spot in common, you'd round to the one spot. If they have the thousandth spot in common, you would round to the thousandth spot. Okay. For multiplication and division, we round based on the least number of significant figures. So now we're not looking at decimal places or positions in the number anymore. Now we're just looking at total number of significant figures. So in the example they give you, 3.0 has 2 significant figures and 12.60 has 4. When we multiply them, we get 37.8000, which we would round off to be 38 because we need to round to the least number of significant figures, which is 2. Right? So it's important to keep straight that the rules for rounding for multiplication and division and then for addition and subtraction are slightly different from each other. If you're adding and subtracting, look at the last common place. If you're multiplying and dividing, round to the least number of significant figures. And remember, we're just doing this so that we are not reporting any information that we don't actually have. Now let's talk a little bit about rules for rounding. Okay, most of these are going to be the same rules you've been using for rounding your entire math career. Okay, so that they shouldn't be all that unusual. Okay, if the digit you're dropping is greater than 5, then the last digit that you are keeping goes up by 1. That's pretty standard, right? If the digit you're dropping is less than 5, then the last digit is just left as is. So 12.4 is rounded to just 12. If the digit you are dropping is 5, and any number after it is not 0, then the last remaining digit is increased by 1. For example, if you have 12.51 and you're dropping that 5, because there is a 1 after it, we round up to 13. If there were just a bunch of zeros, or if they didn't indicate to you any numbers past that, then you would not round up. Okay? Instead, you would drop down to rule number 4. If the digit to be dropped is 5 and it's followed only by zeros, the last remaining digit is increased by 1 if it's odd, but left as is if it is even. Okay? So, 11.5. We are dropping the 5, and the only numbers that come after the 5 are zeros, or they've not written any numbers, and so we are assuming they are zeros. Then we are just going to round that up to 12 because the 1, the digit you're keeping, is odd. But in 12.5, because the digit you're keeping there is 2 and it's even, you're going to leave it as is. The reason we do this is so that if you're dropping the 5 digit and it's only followed by zeros, we round up half the time and round down half the time to avoid giving a bias. Really, the majority of the time, you're going to have numbers that you are dropping that are greater than or less than 5. You're probably not going to run into this last case scenario very frequently. But if you do, this document is always on Google Classroom to refresh you of what the rules are for rounding that. Okay? So, then the last piece on here is just a warning for you. Okay? If you use a calculator and you type down, like you type in the whole problem from start to finish, and you don't write down any of the in-between results, your calculator doesn't always follow the rules of significant figures. And so you might wind up with an incorrect answer because your calculator messed you up. Now, I am absolutely not, and I don't want you to think that I'm saying you cannot use a calculator. Please use a calculator, okay? They are very helpful, especially when we're working a lot of calculations. They help minimize the number of small errors in math that we make. But what I am asking you to do is to do it in steps and write down the answers you get in between so that you catch errors in significant figures that way, okay? So, in a long calculation that involves mixed operations, you want to carry as many digits as possible through the entire set of calculations and then round the final results appropriately. Okay? So, in this first example, okay, the first division should result in 3 significant figures, and the last division that we've done should result in 2 significant figures. Okay? So you can see in that first one, we have the 5.00 has 3 significant figures and 1.235 has 4. So because we're rounding to the least number of significant figures, that division should result in 3 significant figures. And then the 6.35 divided by 4, the 4 only has 2 significant figures, which means that division should result in 2 significant figures. Okay? And then when we add the numbers together, the 3 numbers added together should result in a number that's rounded off to the last common significant digit occurring furthest to the right, which in this case means that the final result should be rounded with 1 digit after the decimal. The correct rounded final result should be 8.6, and this final result has been limited by the accuracy in our last division. If you carry all digits through to the final result before rounding, then you will be more accurate. Okay? If you're rounding the intermediate results when you're calculating, then you can compromise the accuracy of your results. So carry as many digits through in your calculations as you possibly can until the end, but then look back at the problem to figure out how many significant figures you should have. Okay? If you get stuck on the homework, on the long problems when there are both multiplication and division and subtraction, let me know. I am more than happy to help you work through them, okay? And I know this is a bear to understand because there seems to be a lot of these really small nitpicky rules, okay? I am going to expect your answers in chemistry class from here on out to be reported in the correct number of significant figures. Now, I'm not saying it's going to cost you the entirety of a correct answer on the test, but I do expect you to be following these rules and trying to use them, okay? As we discussed, there is important reasons why we do this. It has to do with wanting to report the most accurate information possible, and there are lots of fields that you might go into where accurate information is very important, okay? I'm not saying that every career you go into from here on out is going to expect you to use significant figures, but it's highly likely that if you wind up having to take a chemistry or a physics class in college, that they will expect you to know about significant figures. So that is why I am going to be a bit of a stickler about them this year. Okay? All right. Your homework is just a worksheet that is all practicing significant figures. It's on Google Classroom. I want you to work on it today and come with it as completed as you can tomorrow. And then if there are problems that we need to run together as a class, we will, and then we'll go over it so that you can see how the problems are done. All right.